Hi, welcome back. In today's video, we're going to talk about inscribed angles. Before we talk about what an inscribed angle is, let's look at these two pictures on the left and on the right so you can see the difference between a central angle and an inscribed angle. A central angle is what we've been discussing so far. The angle, if it's coming from the center of the circle, the angle here, angle A, is the same as the measure of the arc BC. This angle on the outside should be congruent. This is measure of BC. So if we're talking about measure of arc BC, we're also saying it's the same thing as measure of angle A because it's coming from the center. On the right side, an inscribed angle is defined where the angle lands on the circle. So it's not from the center. And instead, it creates a different relationship. Since it's not in the center, angle R will now be half of the angle from Q to S, from here to here. I can technically draw a picture, if you like, the dotted lines, of where QS is coming from. QS is technically coming from here. So this angle QS, since we're now dealing with it on the circle, we're going to say it's going to be half the amount. So let's say that we have this this formula we can create. Measure of angle R is equal to half measure of arc QS. In terms of words, the inscribed angle, this is our inscribed angle. The inscribed angle, let me move this a little bit to the left. The inscribed angle will always be equal to half of the measure of the intercepted arc. So whatever angle QS is, we take half of that, and that's the measure of angle R. Let's check out some examples. Here we're trying to find the measure of angle P, which is this angle. Angle P is directly across from this arc, 70 degrees. So if that's 70 degrees, we're going to take half of that, since it's an inscribed angle, and we're going to say that measure angle P is 35 degrees. Same thing with measure of arc PO. PO goes from here to here. This arc, the measure of the arc, should be twice as much as the intercepted angle. So this inscribed angle of 56 degrees, we multiply it by 2, and we get 112 degrees. As opposed to before, when it's coming from the center, it just equals to the angle on the outside. But when it's coming to an inscribed angle, like here, if the angle lands on the circle, now we're dealing with half the relationship. The angle on the circle will be half of the other one. Look at measure of arc CF. CF is dealing with this portion. That angle is being created from here with D. Since angle D is 40 degrees, we're going to multiply it times 2 to find the arc here. We'll call that 80 degrees. Similarly, angle C, I'm going to use a different color so we can tell them apart. Angle C is connected to the other side of the circle. This angle lies opposite to 98 degrees. So since we're dealing with the arc is 98, we're going to cut that in half to go to the inside. And half of 98 is 49 degrees. So if you're given the inscribed angle, we double it to find the outside. If we're given the outside, we cut it in half to find the inside. However you want to think about that. Now, what happens when we have two inscribed angles? Let's see if I can lower this a little bit. If we have two inscribed angles, like angle B and angle C, angle B is in red, notice how this angle B, is connected to from D to A. That's going to be half, right? Angle B will be half of DA. If I have another angle that intercepts the same arc, let's call it C, from C to D, this is going to intercept the same arc, which means it should also be half of that amount. That means that these two angles are congruent. Angle C is going to be equal to measure of angle B, because they're both half of measure of arc DA. They're both half of measure of arc DA. Okay, so let's try some examples. Here we have angle T and angle U. T opens up to this opposite side, SV. This is SV. And at the same time, we have angle U opens up to the same side. Since they both open up to the same angle, we can say that this angle should be congruent to this angle. So that's our equation. 3x minus 5 will then equal 2x plus 15. And then we solve for x. We can move the 2x over. From here is just algebra, right? We have x minus 5 equals 15. Move the 5 over, do the opposite. X equals 20. If I wanted to find the measure of the angle, I would just plug it back in and for x, and I could find angle T or angle U, and we're good to go. Let's look at over here this other scenario. Now here it looks like there's more going on, but if I'm looking for angle R, notice how angle R, for this first question, angle R opens up to ST. At the same time, angle Q, I'll do this in the same color, angle Q opens up to ST. So these two angles, since they both open up to ST, they're both congruent. So angle R is just the same as angle Q, which is just 32 degrees. I'm going to erase it a little bit to clean up for the S. Let's look at angle S. Angle S opens up to the other side. It opens up to RQ. Angle T also opens up to the opposite side of RQ, which means angle S and angle T are congruent. That means that 5x plus 4 should be equal to 6x minus 2. I can solve for x by moving the 5x over. 4 equals x minus 2. Move the 2 over. X equals 6. Now, we're trying to find the measure of angle S. So we take the 6 and we plug it in for angle S. So we got 5 times x plus 4. 30 plus 4 is 34 degrees. If at any point you need to pause the video and you need to, slow down to take your notes, feel free to do that. Feel free to pause it after one example, try it yourself, see if you get to the same scenario as us. Now, an inscribed angle is an angle who lies on the circle. An inscribed polygon is very similar. Right? As you can see here, we have polygons. We can have a quadrilateral or a triangle. That means that all the vertices on the circle are on the circle for the polygon. Whenever you have a right triangle, whenever you have a triangle that whose one of the lines goes through the diameter, we're going to say that this is 90 degrees. It's always going to be a right triangle. Now, why is that so? If you think about this as a inscribed angle, and just look at angle G alone, angle G intercepts half of the circle. So if half of the circle is 180 degrees, what happens when we cut that in half? It'll always create a right angle. That's why when we start adding this triangle in there, where it intercepts the diameter or the middle, it'll always be half of 180. So as you can see in this example here on the right, we have a right angle here. And now we can see that we have 3 given angles, and we know that the sum of the 3 angles will add up to 180 degrees. So we got 4x plus 2 angle F plus angle G plus angle H should equal 180, because we're still dealing with the angles within a triangle, except that in this case it's a right triangle. If the triangle goes through anything else, so let's say that I have a scenario over here. If I have a triangle that does not go through the center, I cannot assume that it's a right angle. At this point, I don't know what these angles are. They have a different relationship. Okay? One of the lines has to go through the center in order for that to be a right angle. From here, we just do a basic math. We have 9x plus 4x, that's 13x. Combine like terms, the x's get combined. We have 90 plus 2 is 92. Subtract 3 is 89. We move the 89 over. 13x equals 180 minus 89. It's 91. Is that 89? Let's see, 92 minus 3. Yeah. And then the 89 divided by the 13 on both sides. X equals about 6.85 or something. If I want to find the measure of the angle, I just take the value and I can plug it in for F. Okay, let's check out this next scenario. We have a quadrilateral that is inscribed. Quadrilateral being a 4-sided polygon. We'll get more into quadrilaterals in our next unit. For now, if we have a quadrilateral that is inscribed, it means that all the vertices are going to be on the circle. What this property talks about is that the angles that are opposite to each other, notice how that angle, I'm going to do the opposite angle over here. They both intersect here and here, which means they're both going to go through the center of that circle. What this property says is that angle L plus angle N, should equal 180 degrees. Opposite angles are supplementary, which means they add up to 180. Same thing can be said about angle K and angle M. Angle K plus angle M should also be equal to 180. So here we have a scenario. Notice how we have 2 angles opposite of each other. These 2 angles, K and H, are opposite. So if I want to solve for x, I can say that those 2 add up to 180. 2x plus x plus 21 is equal to 180. And then I just solve, right? 3x plus 21 is equal to 180. Move things around. 3x equals 180 minus 21 is 159. Divide both by 3. X equals 53. So if I wanted to find the measure of angle H, I would just take x, sorry, not 53 degrees, it's just 53. I can take the value of x, plug it in for H, 53 times 2, and I get 106 degrees. Similarly for angle G, I notice that G is opposite to J. So that means that these two angles opposite of each other will add up to 180. And I can do another equation that says 3y plus 9 plus 4y minus 11 equals 180 degrees. Combine like terms. Move the 2 over. 7x equals 182. When I divide both sides, I get x equals 182 divided by 7 is 26. Now that 26, to find the angle, all I have to do is plug it back in here, and I can find the angle G. So that's 4 times 26 minus 11. Which is 93 degrees. Here we have a bit of a review of the different scenarios that we spoke about. This would be a good moment to pause and try to do these on your own. Try to see if you can find, try to see if you can find the value of these 3 different scenarios so you can identify what you have covered in this video. I would pause it, I would try this on my own right now, and then check back in to see if you got the answers correctly. Okay, so I'm trying to find the measure of arc GH, this arc. I know that 20 degrees is inscribed, so that means that from here to here it'll be double. So this is going to measure 40 degrees. Since we're dealing with half of a circle, that means that half of a circle is 180 degrees. And then we subtract to find leftover, right? 180 minus 40, that means that this leftover piece is 140 degrees. In this next scenario, I have angle A. Angle A opens up to CD. Angle B opens up to CD, which means A and B are congruent. 5x should equal 7x minus 8. Move the 7x over. Negative 2x equals negative 8. Divide both by negative 2. X equals positive 4. Since I'm trying to find the angle, I take my value. I plug it in for the angle. 5 times 4 is 20 degrees. So, to find angle C, now I want to look at the other side. I'm going to erase this a little bit. To find angle C, I'm going to do the other side. Angle C opens up to arc AB, which means angle C will be the same as the other angle that opens up to the other side. These two are the same. So I can make an equation that says 4y plus 7 is equal to 5y minus 3. And then I can just solve for x, or for y in this case. I move the y over. 7 equals y minus 3. Move the 3 over. Y equals 10. To find the angle C, I just take the 10, and I plug it in for angle C. So 5 times 10 is 50. 50 minus 3 is 47 degrees. In this last example, you can see that we have an inscribed quadrilateral, which then implies that the opposite angles are supplementary. So angle B is opposite to angle D. So that means that angle B and angle D, 3y plus 4 plus 2y plus 16 is equal to 180. Combine like terms, solve for y. 5y plus 20 equals 180. Subtract the 20. 5y equals, what is this, 60. Divide both by 5. And y equals 32. I can use the y to plug in to find the angle. Take that, plug it in here, and find the angle. Yeah? 32 times 2 is 64. 64 plus 16 is 80 degrees. Angle C is on the other side. Angle C is opposite to angle A. That means that these two angles add up to 180. 2x plus 58 equals 180. Let's solve for x. Minus 58. 2x equals, what do you got, 122? Divide both by 2. X equals 61. If I want to find the measure of angle C, I take the value and I plug it in for C, which is just 2 times x. So 2 times 61 is 122 degrees. Alright guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate it.